Welcome back to our videos. This is number 1.4, combinations of functions. What we're going to do today is look at ways that you can combine functions, and we're going to start with these two functions, f of x and g of x. F of x is a linear function, 3x plus 4, and g of x is a quadratic function, x squared plus 3x minus 1. Now what we're going to do at first is we're simply going to take these two and we're going to practice our basic adding, subtracting, multiplying, and dividing. So first of all, example 1. Let's do f plus g of x. And this is just saying let's add the two functions together. So that would be the f function, 3x plus 4, added to the g function, x squared plus 3x minus 1. For a final answer of, put together whatever you can. We're going to have x squared plus 6x plus 4 minus 1 is 3. X squared, 3x plus 3x, 6x, 4 minus 1 is 3. Now, if you had, for example, you wanted the value of f plus g of 2, then you have two choices. You could do f of 2, which would be 3 times 2 plus 4, which is 10. You have g of 2, which would be 2 squared, 4 plus 6, 10 minus 1, which is 9. And then you could simply add the two together and get a 19. Or you could take this combination function right here, x squared plus 6x plus 3, and evaluate that for 2, and you'd get 4 plus 12 plus 3, which is also 19. So I guess what I'm telling you is that when you want to do a combination function, you can add the functions first and get a new function and then put the number in, or you could put the number into each of the separate functions and add the results together. This is the addition function, f plus g. Number 2, let's look at f minus g of x. And so that says, now remember subtraction's not commutative, so if it says f comes first, this would be defined as 3x plus 4 minus, and then put some parentheses so you get the signs right, x squared plus 3x minus 1. And let's simplify. 3x plus 4 minus x squared minus 3x minus minus, which is plus 1. You're going to lose the 3 x's. And the value of this subtraction is negative x squared plus 5. So this is f minus g. Now that is not going to be the same as g minus f. If you had g minus f, you would write the g function down first and then subtract the f. All right, I'm going to keep the same front sheet because I'm going to keep those functions. Let's look at f times g. This is number 3. This is f times g of x. And that says, take the f function, multiply it times the g function. So let's do the f function, 3x plus 4, multiply it times the g function, x squared plus 3x minus 1. Now there is no shortcut for this. This is 2 parts times 3 parts. You're going to get 6 parts. Don't be ashamed to draw arrows. 3x times x squared is 3x cubed. 3x times 3x is 9x squared. And 3x minus 1 times negative 1 is negative 3x. Plus, come back with the 4. 4x squared plus 12x minus 4. Put together anything you can. We'll have 3x cubed plus 13x squared plus 9x minus 4. Now again, this function doesn't have any meaning right now. We're just playing with the numbers. But you could then find the value of f times g of 2 by putting in a 2 for x, or you could do it in the beginning, put it into the individual functions. And finally, let's look at the last of our operational functions here. Let's look at f divided by g of x. And again, this is not commutative, so if f's on top, make sure the function is on top. 3x plus 4 divided by x squared plus 3x minus 1. Now, because this is a fraction, if there is something that makes the denominator 0, you need to exclude those values. I made this up at my kitchen table, so of course I don't know what the roots of that equation are. I could find them by putting them in the quadratic formula. But let's just say that there was some number that gave you a 0. You would say, for all real numbers, x is not equal to whatever that would be. But this is the quotient form. If you want to know what f divided by g of 2 is, you can put 2 into the f function, which again would be 10. Put 2 into the g function, which would be 4 plus 6, 10, minus 1 is 9. And the value of f divided by g of 2 would be 10/9. Now these are our computational functions where we can add them, subtract them, multiply, or divide them. I want to show you one more thing that we're going to do tonight, and that is we are going to do some composing. This is composition of functions. Now the symbol for this, you might remember from Algebra 2, is a little open circle. Let's take these same two functions, f and g. I'm getting somewhere with this, I'm sorry. I tell you what, I'm going to get new functions because those are a little complicated. Let's do two linear functions. Let's do f of x is equal to 2x minus 4. And let's make g of x negative 3x plus 1. Those are just two random linear functions that I picked up on. All right, so what we want to do is we want to talk about what it is to compose functions, and this is the symbol f composite g of x. It kind of looks like the word fog. This means f composite g. Now what that means is you're going to put g into the f function. Put g into the f function. Now, in the place of the variable. So instead of 2x minus 4, you're going to do 2 times, and you're going to leave a blank, 2x minus 4. And in that blank, you are going to put the entire function g, which means we're going to put negative 3x plus 1. So truly, it always goes from the tail. G goes into f. The g of x goes into f. So this is g of x right here. Let me get my red pen and mark that for you. This is g of x, and we have planted it right in the middle of the f function. So the final result here is negative 6x plus 2 minus 4, which in final simplified form is negative 6x minus 2. Now, let's go back and do f composite g of a value 3. Here's another way that you can do this. You can come from the tail, put 3 into the g function. So g of 3 would be negative 9 plus 1, which is negative 8. And then once you know that's negative 8, you can put negative 8 into the f function, and f of negative 8 would give you negative, 2 times negative 8, negative 16 minus 4 would be a value of negative 20. Now this is the value I'll be looking to check when I put 3 in right here, and you can see I would get negative 16 minus 2, which is negative 20. Now the composition of functions does not need to be difficult as long as you remember to always work from the tail. Let's do one more example of this. Let's do a linear function. Let's let f of x be 2x plus 5. And let's let g of x be a quadratic function, x squared plus 2x plus 1. Okay, now let's look at the composite function f of g of x. All right, so that says take the g function and put it into the f function. So remember how we do this. Instead of saying 2x, we'll do 2 blank plus 5. And then on that blank, we're going to actually put the g of x function. We're going to embed that function inside the f function like this. So instead of 2x plus 5, it's 2 times g of x plus 5. Final answer, 2x squared plus 4x plus 2 plus 5. And we'll simplify that. 2x squared plus 4x plus 7. Now this is a composite function, f composite g of x. Again, it still has variables, it doesn't have a value. If you wanted to do f composite g of 4, look at it this way. Get my red. You can put the 4 into the g. So that would be 4 squared plus 8 plus 1, which is 16 plus 9, which is 25. And then take the 25 and plug it into the f, which would be 2 times 25 plus 5, which is 55. Now most of the time when we're working with numbers, we will do them separately. We'll put the first number into the first function and then put that number into the f function. But you can watch, this was what we got for our value of our composite function. So let's put 4 into that. It would be 2 times 16 plus 4 times 4 plus 7, which would be 32, plus 16 plus 7, which is also 55. Now you might wonder, what are we doing with these composite functions? What is the point of composite? Oh, wait, let me do one more thing before I leave that. What about g composite f of x? Is it the same thing? No. This says put the f function into the g. So let's take g. It says x squared, so we'll say blank squared plus 2 times blank plus 1. Everywhere there's an x in the g function, we're going to leave a blank. And on that blank, we're going to come back and we're going to put 2x plus 5. Think of this as embedding a function inside another function. So this is what we've got. Now let's simplify that. 4x squared plus, that's square the first, let's double the product. The product is 10x, so that'd be 20x plus 25 plus 4x plus 10 plus 1. Final answer, 4x squared plus 24x plus 36, and then you could find it for a particular value. So this is not a commutative process. G of f of x, f of g of x, not the same thing. Now, if there's anything that we want to take from this, it's something that we'll use on our next video about inverse functions, and that is this. When f composite g composite of x equals when f composite g of x is the same as g composite f of x, and that value is x, then you've got yourself an inverse function. So when f of x is equal to, when f of g of x is equal to g of f of x, which is equal to x, you've got yourself an inverse function. And you can just remember that because we're going to have our lesson tomorrow on inverse functions, and that'll be helpful for us. Okay? All right, that's almost time to stop, so I'm done for this video. Work on your homework, and I'll see you in class tomorrow. Thank you.